Now that we've created the main feature of our project, which is the climbing, let's add one more called grabbing to grab and move around objects. In the workspace, create a folder and name it Grabbable. Next, in the Remotes folder, create a remote event and name it Grab Object. Let's get to scripting. In the VR local script, add the Grabbable folder to the radius parameters. Now, make sure the code for climbing and grabbing is separated using an if statement. In the player module script, make a grabbing on variable to know what our hand is holding. Next, in the VR local script, if the part is not in the climbable folder, meaning it is in the grabbable folder, create a weld constraint to attach the part to the hand. Also, make sure the weld constraint is parented to the hand as well. Now, let's make another script. In the server script service, create a script and call it GrabScript. In the script, set up these variables. Next, whenever a client fires the GrabObject remote, we'll execute the function within it. Let's add more to this function. If the client fires this remote to the server and the action argument is grab, we'll execute the code for the weld constraint on the player's hand so it can take effect on the server. Let's try firing our GrabObject remote. In the VR local script, go up and reference the GrabObject remote. Then, fire the GrabObject remote from the code with the weld constraint. To stop grabbing the part, go to the input ended event. And if the hand is grabbing on a part, find and destroy the weld constraint and also reset the grabbing on variable by setting it to nil. Now we can let go of the grab part with this code, but it will fall through the floor because can collide is set to false. So, in the grab script, store the initial properties of each part in the grabbable folder. In the GrabObject remote, if the action says release, make each part in the grabbed parts model have collision again. Now, in the VR local script, call the GrabObject remote and give these arguments. The first argument returns a Boolean that checks if it's the right hand. The second argument means that if the other hand is not grabbing a part, or the other hand is grabbing a part, but it is not the same part or parent as the primary hand, it will return release. Otherwise, if the other hand is grabbing the same part as our primary hand or is holding a part with the same parent as the primary hand's part, it will return let go. The third argument is the part our primary hand is grabbing. Lastly, the fourth argument is going to be the part our other hand is grabbing. Now, let's test our grabbing feature. We currently don't have an object to grab, so let's make one ourselves. In the workspace, make a part and name it Table. We'll place our grabbable parts on top of this table so we don't have to crouch down. Drag and resize the table to an acceptable size. Let's also anchor our table to stabilize it. Next, for our grabbable object, duplicate the table and name it Grab. For our code to work, create a model and name it Grab2. Then, parent the part to the model. In its properties, resize it without anchoring it. Then, drag the model above the table. We'll change its brick color so it's easier to see. Now we can test our grab function. Let's approach our grabbable cube. When we press the bumper with the hand that is near the cube, we can see that we are able to grab and drop it. You can hold it with two hands too. While we can grab objects now, we can only let go of them. So, we're going to add a throwing feature. In the player module script, set up these two variables. Next, in the VR local script, insert this code. We'll use the hand grab last position to store the grabbed part's position upon being grabbed. Then, set up a bind to render step on the hand that calculates the velocity of where the hand is moving and the grab part's last position. Now, to avoid lagging the game, we need to unbind the render step. Go to the input ended event and insert this code. Finally, let's test our throwing function. When we grab and try to throw the cube, you can see that the cube doesn't just fall straight down.